In this video, I am going to discuss a tutorial for two-level full factorial design. First, I need to tell you what is meant by full factorial design. A full factorial design is applied when the purpose is to determine which factors are important in the study and the range of value of those factors. Uh, this is the only design that can evaluate interaction among all factors. So the full factorial design tells us about the main effects of the factors, and it also tells us about the interaction effect among the factors. The disadvantages of full factorial design: the number of experiments increase exponentially, time consuming, it does not tell us information about the optimum value. It can tell us information about the main effect as well as the interaction effect, but it doesn't tell us about the information that which value is the optimum value. Costly because number of experiments increase. The factorial model equation, here you see this is the response, here you see this is the constant, that is the intercept, here main effect, and here you see this is interaction effect, and here this part is the residual or random errors. Uh, this tutorial demonstrates the use of design of experiment software for two-level full factorial design. These design will help you screen many factors to discover the important few and perhaps how they interact. The data you will now analyze come from Douglas Montgomery textbook, Design and Analysis of Experiment, published by John Valley and Sons, New York. In this data, a waterboard manufacturer must immediately reduce the concentration of formaldehyde used as a processing aid for a filtration operation. Here in this design you see there are four factors: temperature, pressure, concentration, and stirring rate. Okay, and here the objective is in this experiment the objective is they want to reduce the concentration of formaldehyde and want to increase the yield. Okay, here you see this is a two-level full factorial design. So low level and high level. For temperature, the low level value is 24 and high level value is 35. For pressure, the low level value is 10 and the maximum value is 15. Concentration, the low level value is 2% and the highest is 4%. And for the stirring rate is the 15 to 30. When you want to start work with the design of experiment, so when you click on the software of the design of experiment, so here you will see a page you will see like this. Okay, and in this page here you see the regular two-level full factorial design, and here you will see the thing like this. Okay, so after that what you have to do, you have to select, here you see the black color, here you see you have to select let's go on with the case at the hand, a full factorial design. Click the white square label 2 4, here this one, in column 4. Okay, in the runs row label, here the total number of experiment will be 16. Here you will find a window like this. Here in this window you see the number of factors you have: 4, 1, 2, 3, 4. The name of the factor, temperature. For the first factor A you write temperature, for the second factor B you write pressure, for the third factor concentration and stirring rate. You also need to put the value of the units, and you also need to put the values for the low level and the high level. After finishing this, click next. Okay, here they will be asking, the window will be asking for the responses. So in this tutorial the responses, the number of response is 1, so that is the filtration rate. Okay, and here you need to add gallons per hour. Okay, And here after that you will see the power of the experiment. So here the delta value you need to add 2, and the standard deviation value you need to add 5, and the difference to detect delta is 10, and here filtration rate. Okay, and then you have to click next. So uh, here you will see the design, the power of the design. So here you see the power of the design, that is for A 95%, for B 95%, for C 95.3 and 95.3. Power is reported at a 5% of alpha level to detect the specified signal to noise ratio. Power should be approximately 80% or greater than 80%. So in our case here you see is around 95%. I think this is a good design. Okay, so it should be greater than 80%. So here we have achieved the power, a good power. After that you have to click next. Enter the response data. Here you see the response data. Because in this tutorial I have the data. Okay, in the data already I have in the tutorial, that is filtration rate. So I need to add that data here to the response. But in your case, what you have to do, once you design the experiment, so then you have to save it and take a print, and then you have to go to the laboratory, and then you have to run each experiment. And after running each experiment you need to collect the data, and then you have to feed the data in your design. Okay, but already I have the data in this tutorial, so I don't need to go to the lab. Already I have the data, so I'm just going to add the data to my tutorial. uh, Already I have added the data, and I have also the choice to sort ascending or descending order. You have the both. So what you have to do, you have to right click on the column, any column, and then you will see sort ascending or descending. You want to arrange the data in the increasing order or decreasing order, so that we can sort as a ascending order or a descending order. Here you will find your data like this. Okay, and in the ascending order, here you see start from the low and it's going to move on. Okay, so standard, and here you see sorting by standard order. This is the standard order, but you can also sort it as ascending order or descending order. You want to see the flow in your data set, so you can see. After that, here you see uh, you have two choices. You can see the actual data, or you can also add the coded value. The coded value means -1 or +1. So you have the both choices, and here you can see display, and here you see process factor, and here you can select either actual value or you can select either the coded value. After that, you have to click on the pre-analysis of effect data sort and sample scatter plot. You want to see the scatter plot among the factors. You want to see the graphs. So you can also select here, or you can select two graphs and you can plot it and you can see it. Here graph columns, and you will see here you see on the left side you will see uh, here you see design actual information notes summary, and here you have the graph columns. So when you click here and you have already selected the data, so you can just plot it and you can see. When you plot the data, so the window will be appear here. Here you see the number of run. Okay, and here you see temperature, pressure, concentration, and the things like this. And here you see the temperature, and here it also when you click here, you see when I click here the filtration rate, so I can find the correlationship. And here when I click on this cube, so I can find here the correlation is 0.571. And here you see this is the correlationship for what? For the temperature. This is for the factor temperature. If you click here, so you will find for the pressure, and here you see when I click here, so I can see the correlationship for the pressure, and here you see the correlationship is 0.083. Here in this slide you can see here the diagram. If you want to see the effect of all the variables or all the factors, and you want to plot it. So you can see here, this is a 3D plot. Here it can show you here the blue color. Here you see the filtration rate. Okay, this is the concentration of the formaldehyde. Okay, what was the objective of this experiment? In this experiment, we want that the concentration of formaldehyde should be the least, it should be the minimum. Okay, because formaldehyde in this experiment, this is a toxic chemical, so we want to keep it at low level, but we want the filtration rate should be high. Okay, so this was the objective. We want to achieve this goal. Okay, so here, so this 3D graph, it can show you the level or the effect of all the variables or all the factors. In this slide, now you want to analyze the result. So here you see on the left side of the window, when you see here, this is your actual design, and here you see the analysis, and here you need to click here. So you will find the window like this. Okay, and in this window they are also asking for the transformation. So in this experiment we don't need any transformation. Okay, because here it shows you response range from 43 to 104. A ratio of the maximum to minimum is 2.4. If this ratio is greater than 10, so then you need to go for the transformation, but it is less than 10, that is 2.4, so you don't need any transformation in this design. Okay, so you just go for the analysis. The first thing you have to choose it, you have to see here. From the here you see the effects. From the effects you click on the effects. So from the effects here you will see the half normal plot. This is a very important plot. Okay, it tells you about the main effect. Okay, so those variables, those values which are lying under this line, okay, so those are least important. They have no effect. They have no effect on the on the on the on the on the on our objective and our response. But those values, those are away from this normal plot. Okay, so those are very important, and they have effect in our experimental design. Okay, so here this is it shows you this cube, this 1 2 3 4 5, these 5 cubes or these 5 points are very important for us. So what you have to do, then you have to click on each point and you have to select it, and after selecting this, and then again you have to go for the next, and then you have to see what is the effect. So here we have selected all of those, and here you can see. Okay, select it, and then you have to see, then you have to go for the Pareto chart. This is very important chart. Here you will see different types of charts: half normal plot, half normal plot, Pareto chart, and uh, many others. So here you see you have selected temperature. These were the points. Those were not on the normal plot. Okay, so they were having main effect, and here you can see the temperature, AC, AD, and stirring rate, and it shows that these are the factors. These are the main. They show the main effect. They show the effect on the response. And from here you should see, here you can also see M, the term will be considered for the model. E, the term will not be considered for the model. The term is that is confounding, lies with another term. Okay, and here indicate that the term was manually forced into the model, indicates the term is required to be in the model. After that, here you see, then you have to go to for the ANOVA. Okay, and after ANOVA, we have to look to the p-value. This is the most important point. We have to search for it. The p-value should be less than 0.05. Okay, so for those factors for which the p-value is less than 0.005, so those are the important factor. Those are the they show the main effect on the response. Okay, so in this case here you see the model is having the value, the p-value is 0.00, that is less than 0.5, so our model is significant. Here the temperature, here it's also having significant effect because the p-value is less than 0.05. The concentration also, and here you see the stirring rate, and here all of those. So the ANOVA table give you a picture about that what you are going to do, and you are on the right direction or you are not on the right direction. So this is a very important chart. From here you can see the effects of the variable on your response. Again, here you see this is normal plot of residual. Okay, you know what is mean by residual? Residual is actually this is the error term, and residual we also known as random error. So this plot, it should show you that the error should be distributed normally around the normal plot. Okay, there should be no trend, not in one direction or not in the other direction, but they should distribute normally around the normal plot. So in this case it's okay because the distribution is normal. There is no nothing that is you can say that is not that is awkward, so it's okay. In this case everything is normal. Here again you can see the residual versus predicted. So you have to select residual versus predicted, and you will see the plot like this. Again you can see this is the zero line, and from the zero line the distribution is again is okay, normal, and it is okay. You can also see residual versus run. Again here you see, and these red lines, it shows it actually tell you as in your data as there's some value that show outlier. Outlier means they are having different behavior as compared to the others. So in this case here you see there is no outlier. Okay, the behavior is not abnormal, everything is normal, so it's okay. After that, you can also see the box plot. This is a very important plot. Here, box plot, it shows you here. In this plot here, you see the blue value, okay, and here it's the red value. If this blue value uh, comes after the red, so it shows that something is wrong in your model. But in this case here you see the blue value is in front of the red line, so it shows that so, okay, your model is moving in the right direction. For those who want to into the detail, so the box screen is a color code to help with the interpretation. The blue line shows the current transformation. In this case, it points to a value of 1 for lambda, which symbolizes that the power applied to your response value. A lambda of 1 indicates no transformation. The green line indicates the best lambda value, while the red line indicates the 95% confidence interval surrounding it. If this 95% confidence interval include 1, then no transformation is recommended. It boils down to this: if the blue line falls within the red lines, so you are in the optimal zone, so no change is necessary in your response. So here you see the blue line is uh, in before the red line. So in this case here you see you don't need any transformation. But if this blue line was coming after here from the red line, so then it will tell you that you need some transformation. So the box class plot can tell you about that do you need any transformation in your model or you don't need any transformation. So if the blue line is coming before the red line, okay, so it means you don't need any transformation. But if it is coming after the red line, so in that case then you have to go for the different types of transformation. Here you can also see the report of the box class plot, and here you see base lambda minus 0.54. The low level is minus 2. If you remember, I told you in the beginning, if the lambda value is greater than 10, so you need to go for the transformation. But if it doesn't, if it lies below the 10, so it means you don't need. And here you see recommended transformation, none. You don't need any transformation. You don't need to go anything further transformation in this case. Here you can also see the main effects and an interaction. Okay, so here you have to choose here. Again, you go to the model graphs, then the AC interaction plot comes by default. Okay, display option, here you see here, this is the interaction. It shows the interaction between the concentration and the temperature, and here from here you can choose the run and the AC interaction, or you can select any other kind of interaction, any other time between the any other two factors the interaction. So from here you can choose that is there any interaction between AC or AB or AD or something. So from here it will show you the type of interaction that exists among the factors. Here from here you can see A, B or C or D or AC. So it will show you the type of interaction. Here you see the temperature and stirring, the D, the interaction between these two. Again, there is some interaction effect. Here you can also change the level from here to move or to drag it. This is the cube plot. The cube plot show the effect of all the variables, and that is on the filtration rate. And here you see this is the 3D plot of the interaction and also filtration rate of response. From here you can also see here. You can also add a flag if you right click over here under it on this surface plot. From here you can also see the 3D view of the surface plot. These are different types of the surface plot. And confirmation at the end, the last feature that we'll explore at the lower left of the screen under the main branch of the post analysis. Click the confirmation node to make response prediction for any set of condition for the process factor. Then click the factors. When you first enter this screen, the factor tool was default to center point of each factor. Level are easily adjusted with the slide bars or more precisely by using sheet view. In this case, the analysis suggests that you should slide the factor as temperature right to its high level. The model is suggesting you that the temperature you need to take it to the highest level. Pressure leave at default level. This is the model is suggesting you. Concentration left to its low level, because you remember in the beginning I told you the objective was we wanted to reduce the concentration of formaldehyde. Okay, and the D right to its high level. And when you put this, and that you can slide from here, this is the slide bar. So here the temperature is toward the highest value, pressure is a default value, and the C concentration should move toward the left side to the minimum value, and the stirring rate should at the high. And here you can see the results. So at those conditions you will get here filtration rate will be mean is 100.625, median is 100.625, standard deviation in this model is 4.4, and the standard error operation is 5.1. And here you see the 95% PI low is 89.08 and high is, and here you see this is it tells you everything. This is the complete diagnostic of your design. Again, here you see confirmation location 1, and here you can see here 92.5, 103. So all the things you can see here, and here you can also see the statistic of your model of your design. Then you need to save it, and you can export the data to Word format or Excel format, and anywhere you need it. Thank you. Dear students, in this tutorial I'm going to show you practically how to work with the software design of experiment, and how to make a full factorial design for 2 level. Okay, so when you open design of experiment, okay, so you will see the window like this. Okay, And in this window here, you see you should select on the left side here, you see you should select the regular 2-level full factorial design. Okay, and here we have 4 factors. So for 4 factors here, you see you have to select 2 to 4. Okay, here you see this the black spot, and here you see the total number of run is 16. Okay, and here the number of replicates you have to add 1. Okay, and then you have to click here to continue. Okay, so here you are getting A, B, C, D. So in horizontal you have to click to show by horizontal way, and for A you need to add here because already you have for A you need to add temperature. For B here you need to add here pressure. For C here you need to add, because we need to add the name of the factors, concentration. For D here you need to add the stirring rate. Here you can also add the units. For here you see the unit is DEGC. Here you see the PSI G, and here for this one here you need to add the percent. Okay, and here the stirring rate you need to add RPM. Here type, here you need to type, you can right click numeric or the other one, but here you want numeric. So the low level here you see you have to add 24, and the maximum level here you need to add 35. In this case here you need to add 10 for pressure 10, and the maximum one you need to add 15. Here you need to add 2, and the maximum one you need to add 4, and here you need to add 15, and here you need to add 30. After feeding the values in this regular tool level factorial design, you need to click continue. Here now you will see the window. In this window they are asking you response. How many response you have? You can add 2, 3 or 4, but in this case we need to add 1, so you choose 1. And here the response, for the response you need to add here you need to add filtration rate. The name is filtration rate. Here, and here the unit is asking, this is the gallons per hour. Here for the delta value, this is the delta value. Here you add 10, and here you need to add standard deviation value 5, so here you will get 2. Okay, and then here you have to continue, so you will see the power. Here you see the power, the minimum power you need to be not less than 80%, and in our case here you see 95.3, 95.3 for B, 95.3 for C, and this is a very good power for our model. So you click here finish, and here this is your design. You can save it, and then you have to go to the lab, because here you see you have the total number of experiment is 16. Okay, so those experiment, the total number of run here you have 16. Okay, and here then you have to each row show you one experiment, so you have to take print of this. You have to go to the lab, and there in the lab you have to critically perform the experiment, and after that you can here you can find the you can feed the value for the response over here. But in this case already I have the data, so I will just add the data from my, already I have it, so I don't need to go for the lab, and I have, because I'm just giving to give you a demonstration how you have to work with the design of experiment for 2-level full factorial design. Okay, so I'm just going to open, already I have the data. Let me check where is the data, so I can choose from over there. In this case the data will be in the, here I will see the, let me see where is the data with me. I have saved it. So this is the filtration 2 level full factorial design. Already I have the data for this one, so I can load the data. And here you see the data is here, and already I have fitted the value for the response over here. If you right click on the standard, here you see you can start ascending or descending. It's up to you. If I want to start descending, so I can do here. Okay. In the display option here, if you click here and use, you can also, as I told you before, you can also, this is actual value, but you can also show you in the coded value, like 1 minus 1, because for the maximum one you are adding plus 1, and for minimum one you are adding minus 1. So, but in this case I will work with the actual value. Here you can select here, you can also right click here and you can start ascending or descending, is up to you. So you can work here like this. Here then you have to go to the graphs. You want to see the effect of the graphs. Okay, so from here you can just go click here the graphs. Which factors you have to select, one or two, these two, between these two you want to see the graph. Okay, so here you can see the graphs between two or many. Here you will see here, and here you have the filtration rate for this. Here you can see the correlation is here, this one. But if I click here, you see the correlation, I will see the graph for another one. If I click here, so I can see the correlation is changing here for this one, and for here you see for this one the filtration rate. So this is the correlation is 1, and here you see. So from here you can see the correlation for the among the different graphs. So that is the option you have. You can see it. From here you can also see the run, or you want to design, or you have the different choice. Okay, so you can choose it. After that you can also see here the graph. From here you can see different thing. After this you have to go for the analysis. Here you will see the analysis table. Okay, and here, because it shows you that the ratio of maximum to minimum is 2.4. okay, a ratio greater than 10 usually indicate a transformation. Here we have the ratio that is 2.4, is less than 10. Okay, so we don't need any transformation. So I think in this case transformation is not needed. Okay, so we just go for analysis, and here you see the effect. So you have to come here, and this is the half normal plot. Okay, so those values that are lying on the normal plot, so those are least important. They have no effect, major effect on the response. But the values, those are here. Okay, this value, and here this one, and here this one. Okay, these are having effect on the response. Okay, so you need to select those one. Okay, and after that you have to go for what, you have to half normal plot, you have to select, and then go to the Pareto chart. Okay, so after that you have to go to the different types of chart, normal, graph, interaction. Here you see the transformation and effects. Okay, I have to see here the Pareto chart. Here you see in the Pareto chart, here you see the important temperature, AC, AD, stirring, and here you see the concentration. So all these are very important, so that you can change. So this is, here you see this is the Pareto chart, so you have to select from here, and from all those you can see, you can select. Okay, so this is the Pareto chart. So in our case there is nothing is abnormal here, you see. So after that, here you have to go for the model terms. You have to see here the model terms. Okay, from here you can also see the normal plot, Pareto chart, numeric value you can also see here, and here you see the model terms. Okay, and after that here you have to go for the ANOVA table. You have to look up the ANOVA table. Here you see the model is giving you this 0.01, the value is less than 0.05. Okay, so model is significant. Again for the temperature, here you see it's significant, and here you see, so those value less than 0.05, those are significant. So here you see this is this one here, this one stirring rate, so you have the things. Okay, the ANOVA table, here you can see. From here you can also see the R square values, you can also see the coefficient values, you can also see the equation, and you have different choices. From here you can see it. You can also see the normal plot. From here you can see the normal residual plot, or you can see the normal plot. Here you see the normal plot of residual, and here you see the random errors are normally distributed, nothing is wrong here. From here you can also select residual versus predicted. Again here you can also see, here from here you can see residual versus run, predicted versus actual, and from here again you can see a very important plot, that is box plot. Here the green line indicate, here you see the green line indicate the best value for the lambda 1. The blue one is in front of the 2. So from here you can see that in your model, do you need the transformation or you don't need the transformation. If the blue line is after the red line, so in that case then you need the transformation. But here in this case the blue line is before the red line, so we don't need any transformation. So the box plot for power transformation, from here you can see that you need the power transformation or you don't need the power transformation. Here you can also see the after that you have to go for the interaction. The effects are the interaction, main effects are interaction. Okay, Here you can see the different types of interaction. Here, from here you can select, you can choose here the temperature and the pressure. In between the temperature and pressure there is no interaction, okay. But if you select here, you can, from here you can choose, okay, this is the default sheet. From here you can choose the term A, B, C. If you look, click to the A, the temperature and the pressure, and you can also change it, so it will show you the different types of plot and the interaction, and you can see from here. You can also see in the sheet here, you see one order, or you can also drag it to the low value and to the go to the maximum value or to the low values. Here you can change, okay. Concentration, we want to reduce the concentration, and here, so from here you can choose what you have to do. Then again A to D, and here you want to see this interaction, pressure high, and suppose the temperature is also high, and the concentration you want to low or increase, so you can see. So this is the interaction plot. Here it can show you different types of interaction, and you can, when you drag it, so you can see the effect, okay. So you want to increase the pressure or you want to decrease, so you can see. So from here you can change. From here you can also see all factors interaction, or you can see one factor interaction, or you can see perturbation, and you can also see you have the different types of interaction. You can see the counter plot. Here you can also predict it versus this, and here you can also see the 3D surface, and here you can also see the cube. The 3D surface, here you can also see here, and here, from here, this is the least, the blue color means the least effect, and here you see the red zone, it's giving you the best effect, okay. And from here you can see, and when you drag it, so you can see the effect. It can be changed, okay. So when I want, .3D surface, you can also see here. From here, the cube surface, you can also see here, predicted. So from here you can see different types of interaction effect you can see here. After that you have to go for the confirmation, okay. You have the different choices, the confirmation, and here is the confirmation. So for the confirmation, here it shows you what you want. So here from here you have to increase the temperature, you have to decrease the concentration, and you have to increase this thing. So from here you will get, look the value. So from here you can see the things, the actual thing. This is the confirmation report, and the maximum, the mean value is 100, 0.2, okay. This one, and here the standard deviation is this is the error, and this is the PI low, and here is the PI high, and here you see the high level, and so everything is giving you. So for transformation, for response, the predicted in median may differ on the different scale. And this report, then you can save, or you can copy, or you can, whatever you want, you can do it. Thank you for watching this tutorial, and please try to practice by yourself. Thank you very much.